This is the first in a series of videos on graphing quadratics, and this one is a brief introduction to graphing quadratic functions. So when we talk about quadratic functions, a quadratic function is simply any function which can be written in this form. F of x is equal to ax squared plus bx plus c, or alternatively, y is equal to ax squared plus bx plus c, where a, b, and c are real numbers. And a is not equal to 0. It doesn't have to be written in this form. In fact, there are two very common forms that this is written in. The first one is called standard form, and that's the first one that we'll graph. And that's in the form y, or f of x, is equal to ax squared plus bx plus c. And the other common form is called vertex, or hk form. And it's written in the form y is equal to a x minus h squared plus k. An example of this might be y is equal to 3x squared plus 6x plus 9, or y is equal to 2x squared minus 10. An example of vertex form might be y is equal to 1/2 x plus 4 squared plus 3, or y is equal to minus 3 x plus 7 squared minus 6. All of these are quadratic functions, and the key here is simply that there's an x squared term. There may be an x term and a constant term, but there's always an x squared term in a quadratic. The graph of a quadratic is always a parabola. And let's talk about the parts of a parabola. A parabola roughly has this shape. It could also open downward like this. It has a vertex, which is either the point which is the point with the most negative value y, or the greatest number of y. One thing about a parabola is that they're identical across from the vertex. So if you imagine an imaginary line that goes through the vertex, the parabola is going to be a mirror image on each side of that imaginary line, and that line we're going to call the axis of symmetry. We're also going to talk about the width of a parabola, being that a parabola can either be wider or narrower. The other important parts about a parabola are the x and y intercepts. The x-intercept is simply where the parabola crosses the x-axis. So an example of an x-intercept would be if this was the parabola, and that's the vertex here, then we would notice that this is an x-intercept here, and this is an x-intercept here. So the x-intercept is simply where the parabola crosses the x-axis. The y-intercept is where the parabola will cross the y-axis. So imagine a parabola that looks like this, and this is going to be the y-intercept right here. And there's algebraic ways to solve for the x and y-intercepts that we'll do in a later video. So this is the first video in an introduction to graphing quadratic functions, and the following videos will step through various problems.